Hello and welcome to the Swallows Charity Head and Neck Cancer Podcast. Join us on a head and neck cancer journey, presented by Derek Luthwaite.
Hello everybody.
And Chris Curtis.
Hello everyone.
We'll be discussing everything that patients and caregivers need to know about diagnosis, treatment, and so much more.
I'm CEO of the Swallows Head and Neck Cancer Charity, and I'm also a cancer survivor for nearly 10 years now.
And I became a caregiver when my wife was diagnosed with mouth cancer, and it certainly put me on a journey that I never expected to experience during my lifetime. Hello everybody and welcome to another Swallows Head and Neck Cancer Podcast. I'm Derek and unfortunately I'm here again with Chris. Hi Chris.
Hi Derek, are you well?
Yeah, I'm grand, thank you. It's been a long time since we did one of these. Must be all of, half an hour is it or so?
At least half an hour. So, but at least I started early than you. I was up at 7:30 a.m. Unlike you being up at 9, 10 o'clock, something like that.
No. Not so late as that. That was the time I went to bed, I think. Anyway, folks, today we are going to be looking at a very interesting subject. We're going to look and talk to a doctor, Dr. Elaine Emmerson, who is a research scientist who looks at work involving regenerative medicine around head and neck cancer patients who have suffered damage during radiotherapy treatment. Now, this is something that you will not come across in any area other than this conversation we're going to have with Dr. Elaine now. Most of you, if not all of you, will at some point be put under the machine and given some radiotherapy to assist in your treatment. And if you're starting or if you're just starting your journey, you will probably not know this yet, but if you're partway through your journey or at the end of your journey, you will know that there are some pretty tough side effects that come with radiotherapy treatment. And a lot of the stuff that we've talked to you about already on these podcasts has been about how you can deal with some of those side effects and treatments that are available. But Dr. Elaine is here today to talk to us about the research that is going on to minimize, hopefully, I guess eliminate would be too big a hope, all these side effects. So first of all, may I offer a huge welcome to Dr. Elaine Emmerson, and she has a list of titles and stuff which is phenomenal. It just goes on forever, guys, and I'm not going to read it all out, but just let me tell you that Dr. Elaine operates a research lab up in the University of Edinburgh, supported by a group of researchers and students, and she concentrates on the, as I said, the regenerative medicine institute. She's a member of the Institute for Regeneration and Repair. She's a fellow of this, a chancellor of that, and it goes on and on and on. She's a really, really big person. So big welcome.
Thank you very much.
Dr. Elaine Emmerson, thank you for joining us. We appreciate you sparing us the time.
Thank you.
Now then, I've given a little bit of a confused outline of where you're operating and what you do. Let me hand it over to you and say, we've got an audience hopefully out here of patients, of caregivers, of professionals, and people family members who are just generally interested in this particular subject. So please tell them just a little bit about you, who you are, and what it is you're actually doing.
Certainly. As you said, my name's Elaine Emmerson, and I'm essentially a group leader. So I lead a team who are undertaking regenerative medicine research, and we're doing this at the Centre for Regenerative Medicine, which, as you said, is a part of the University of Edinburgh. And again, as you mentioned, and this is something that your audience probably needs no introduction into, but radiotherapy, while largely successful at treating head and neck cancer in many situations, often leads to a lot of side effects for patients beyond their treatment. And one of those things is the loss of saliva, which is termed xerostomia in the kind of technical sense. And this is really what my group are researching. So again, as your audience are probably well aware, more than most, there's really no treatment for this at all. And that means that patients rely on sort of palliative care, so things like oral rinses and lubricants and sprays, or even just sipping water all day. And obviously this is a lifelong side effect that people are then living with. And this, again, has a really debilitating effect on quality of life. So what we're looking at is whether we can try and develop something that's a sort of long-term regenerative strategy. So trying to actually restore some of the function to the salivary glands after the damage caused by radiotherapy. And as you said, I've got a wonderful team of scientists and PhD students who are working on various different aspects of this. So we're looking at broadly kind of two approaches. So we're looking firstly if we can find the cells that are the sort of immature precursor cells of the salivary gland, and these cells we term stem cells, and whether we can find these cells in the gland, whether we can take them out before radiotherapy, before the patient undergoes their course of radiotherapy, grow them in a lab, and then whether we can transplant them back in, and whether that can then repair the injured tissue. Or the other option that we've got is to look at the sort of cell environment after radiotherapy and what's changed in that time, what's changed with that injury, and whether there's something that we can try and switch back to how it was before. And this is a sort of method to kind of internally repair. So whether we can try and kickstart the gland into repairing itself after that radiotherapy damage, with the idea that maybe if we can combine these two approaches, that hopefully we'll end up with something that's successful and something that's actually a lifelong treatment. So a means to regenerate the organ enough that somebody can produce saliva again, and obviously that will have a huge impact on their quality of life.
When I first met Elaine, she told me a story of why she does what she does. And to our listeners, this, I think, will be more important, because I've always said when you've got a passion, doors can be opened. When you just do it because it's your living, or, you know, it's something you want to do, or something you've been trained, then when a door gets slammed in your face, you tend not to open up as much. But I know Elaine has had to open loads of doors to get where she is now, and the story is just as important. So if you don't mind, Elaine, if you can just explain to some of the listeners about the story you told me.
Yeah, absolutely. So really, all of my sort of passion and drive behind this comes from the fact that my father was diagnosed with head and neck cancer in 2005. So this was at a point where I was just starting my research career, and I then was undertaking a PhD at this point in actually a slightly different area of regenerative medicine. So I was working on skin and wound healing. But at the time, I wasn't aware of all of the side effects that would come with radiotherapy, and nor with the rest of my family, nor was my father. And it was something that we really struggled with as we were going through his treatment regime, with desperately trying to understand why he was undergoing various procedures, why he was having dental appointments, for example. And even coming from a science background, it wasn't something that I was prepared for or had any sort of understanding at all about. And then actually following my PhD, I had the opportunity to move fields slightly and move to America to do research. And it was then that I actually started working in salivary gland biology. And first starting out looking at development and understanding how the salivary gland grows in the first place. And at this point, it became something I was really interested in trying to apply this developmental biology knowledge to try and understand what happens with regeneration, or the fact that the salivary glands don't really regenerate, and what happens following radiotherapy. And so that's really become the kind of basis of my research and what my research group do. But it's been a really interesting journey, because I think without that personal experience, I wouldn't have had the same interest, and it certainly wouldn't have had the same impact to me. But moving forward and understanding much more about salivary gland regeneration and what's missing, why salivary glands generally don't regenerate very well, I think has only been pushed forward by the fact that I was so close to somebody going through that, many years beforehand.
Yeah, well, that's a huge motivation, isn't it? So
yeah, and from someone that struggles with dry mouth, to think about that work being as good as it is, and the impact it will make on tomorrow's patient. And when I talk about tomorrow's patient, is the ones that don't know they're going to have cancer yet in future years. To think that they could do that eventually, and dry mouth is almost, well, it goes. I think, I've always said 1% different makes 100% different to a patient. And if we can improve all these little 1%, then it's massive. So that's why myself personally and the Swallows is so behind Elaine's work, what she's doing, because as you know, Derek, I would say 99% of our patients in one form or another struggle with dry mouth. And until you live with it, you don't really know what it's like.
Chris, let's take this and Elaine, let's just take it back a step, because we've got a mixed audience here, hopefully, of people who are at the beginning of their journey, and some won't have had radiotherapy treatment and won't be able to understand the impact that lack of saliva has on them until it actually hits them. They can be told all sorts of things, but the reality is a greater shock. But let's first of all, what can we just explain to people? Just what is saliva? What does it do? And why is it so vital? And when you haven't got it, why is it so crippling?
Mm-hmm. So essentially, saliva is what keeps the mouth lubricated. So it's a water-based liquid, but it's full of proteins that are really important. For example, in the first stages of digesting your food. So there's enzymes that actually start breaking down the food even when you're chewing it in your mouth. It's obviously really important in terms of that chewing and swallowing function. So if anybody's ever tried to eat bread, for example, without having a sip of water, you'll find it incredibly difficult after a while. And saliva is really important in keeping that kind of lubrication and adding liquid to that to allow chewing and swallowing and that first stage of digestion. It's also something that's really important when you're speaking as well. And so one of the really good analogies that I use often when I'm speaking in an academic setting is to give people the example of when you're presenting in front of a large audience, often people get nervous, and that often equates to the feeling of dry mouth. So that's actually quite a good analogy when you're explaining, imagine this feeling for the rest of your life. And this kind of gets the message across to people that this is what head and neck cancer patients are living with. And finally, it's not just a sort of lubricant. Saliva is really important in the protection of the mouth and the teeth. So it's antimicrobial, so it protects against bacteria, viruses, keeps the teeth protected. It keeps the mouth protected. So it's also something really important in terms of not getting infections in the mouth, not having tooth decay. So it's all over a really, really important liquid.
I believe I heard somewhere that it also plays a part in your ability to taste.
It does. Yes, indeed. That's true.
So poor old dry mouth like Chris, it's never stopped him talking, by the way, which is a bit of a tragedy for most people, but he seems to have overcome that one. But I do understand that sometimes he eats stuff and it just doesn't taste like it ought to taste anymore. That right?
Do you know
Chris?
what? I also, on a serious note, I also found out from a GP the other day that is looking into obviously saliva and what it does. I didn't realise that when you kiss your partner for the first time, the saliva goes onto the lips, which then generates hormones, certainly in the lady's body, that says whether she fancies you or not. So
that's where I've been going wrong all these years.
I've got no hope now going forward.
Indeed. Well, with that fantastically new scientific breakthrough from Dr. Chris there, I apologise, Dr. Elaine. He's a nightmare to work with. He really is.
You're listening to the Swallows Charity Head and Neck Cancer Podcast.
I understand that radiotherapy is targeted. That you have a mask made and it's all calculated and it's targeted, but I assume that even if it's nowhere near the actual salivary gland location, there's a sort of an overall effect that's taking place there's no guarantee that it's not going to damage the salivary glands. Is there any way of avoiding that, or is that just a case of, listen, that's what's going to happen, and the work you're doing is how do we minimize it and how do we make it hopefully the gland itself regenerate?
Yeah, no, that's absolutely correct. So over the years, the sort of treatment regime has definitely improved. So things like intensity modulated radiotherapy, where it's a little bit more targeted than it once was, has been a huge improvement. But the problem is that it's still not targeted enough to really only target the tumour. And that's really because of the sort of really complex makeup of the jaw and the head, and the fact that there's so much other stuff in there. And what tends to happen is that it's really important to try and avoid the really crucial bits of the head, so the brain and the brainstem and the spine. But still target the tumour. Obviously, that's the priority, is to get rid of the cancer or to shrink the cancer, while also not irradiating these really important structures like brain and spinal cord. So often there are just other bits that just tend to have to be collateral damage, unfortunately, and the salivary glands often end up being those areas of collateral damage. So as much as things are attempted to try and avoid that, sometimes it's just not avoidable at all.
It's a complex area. I could only fall back on my own experience from my wife's cancer, which was obviously in the mouth, and she actually didn't get as far as the radiotherapy treatment, but after her operation she had an excess of saliva. It was like a waterfall almost. She couldn't turn it off, and she was almost thinking, well, maybe the radiotherapy treatment here might slow some of this down. I mean, is it usual? Is it can the radiotherapy actually not only cause dry mouth, but can it cause the glands to actually produce excessive saliva as well? Or is that a myth that I've just sort of come up with?
So to be honest, it's such a complex area that the way that the gland produces saliva, it's reliant upon stimulation, and if that stimulation goes awry for any sort of reason, then you can end up with kind of excessive salivation. And one of the things that we work on quite a lot in my lab is the idea of the nerves being a stimulation property. So if you end up with any sort of effect that then affects the nerves, you can then end up with this sort of overstimulation. There's also quite a lot of evidence that various different drugs that might be prescribed during the course of treatment could also be having that same sort of effect, so overstimulating. But the biggest problem, I think, following radiotherapy is that you most of the time end up with areas of the gland, if not the whole thing, that are just damaged kind of beyond repair. So they don't produce saliva, even if you have excess stimulation. So one of the treatments that is prescribed, but that's not very widely tolerated, is the idea of administering pilocarpine, which basically does exactly that. It tries to stimulate the residual tissue, any tissue that's left that's still functioning, to try and produce saliva. The problem being that if there's not very much tissue there at all, or none at all, then that's absolutely not going to work. But it has so many off-target side effects on other bits of the body that actually it's not a particularly nice drug to take. So the idea of this really fine balance between the gland itself being healthy and being able to produce saliva, but also the signals that cause that stimulation, and whether they're sort of neuronal or whether they're other different signaling pathways within the body. All of that is such a complex situation that probably every single patient is going to be a little bit different, and it's very hard to know before treatment what's going to happen afterwards and what the outcome will be.
So the radiotherapy is impacting on an ongoing basis from session 1 through to the treatment is completed, and the extent of any damage that may or may not be caused, because it doesn't affect everybody. That, you know, we must point this out. Just because you're having radiotherapy does not mean you are guaranteed to end up with dry mouth and no saliva, but it is unfortunately a large percentage that they do. But just taking sips of water is not going to substitute for this lack of saliva. It's not a cure, and it's not an aid to eating or swallowing in the way that saliva is. Mm-hmm. So can I ask you, not without giving any national secrets away here, or anything that we shouldn't know about, where are you at with the research? How's it going? Where are you, and what are your hopes?
So we are currently working on a system whereby we can deliver these signals, so these neuronal signals that I just mentioned previously. And again, the downside of just giving these signals is that they have far too many side effects elsewhere in the body. Mm-hmm. So they're things like excessive sweating, a racing heart, diarrhea, things that patients really do not want to be living with on a daily basis. So what we're looking at is whether we can try and deliver these signals just to the salivary gland. And we're using this what I think is really incredibly clever technology that relies on having essentially a catalyst embedded into the salivary gland, where we can then give this drug in a sort of altered format so that it won't have any effect anywhere else in the body, but where it comes into contact with this catalyst in the salivary gland, it kind of breaks it apart. So you've got this additional piece and this functional drug, and that should then keep it as a drug that's only active in this sort of local surrounding of the salivary gland. And we're really hopeful that that will then lead to a sort of internal repair mechanism of the gland, so it will kind of kickstart into being able to start to repair the damage and go from there into something that's maybe a bit more functional and provides a bit more functional saliva production, for example, for patients.
What I'd like to say is twofold, really. When I'm allowed to go out to a restaurant when COVID is finished and actually sit inside, because I don't see why I should pay £50 to sit outside and eat a meal, but that's another story. But when I do go to a restaurant, she'll always say, "What do you fancy?" I don't fancy anything apart from my wife, who sat opposite me, obviously. But when I'm looking at the menu and I'm looking at it, and it's either fish, pasta, and it's got to have sauce. If fish, pasta, and no sauce is on the menu, I might as well stop at home anyway. Mm-hmm. Now, there's an argument to say she always takes me to an Italian restaurant because they never sell fish or anything. But that's another. But that's me when I look at a menu. I don't, and even like she'll come in, wake up even now and say, "What do you fancy for tea tonight?" Or whatever we have, because I don't fancy anything for tea, and I never get hungry. I don't feel hungry because my salivary gland's not telling me that I want to eat. So, when you start thinking of food, that's normally, as I understand, is when you start understanding, do you know what, I fancy a fillet steak? Because if you think about it, you'll start tasting it in your mouth and all that. Your brain starts reacting to it. I don't get any of that. So that's the reality of living with someone with dry mouth from the carer's point of view. And Sharon would say, so it's not nice when you go out for a meal. I'd love to have a fillet steak. Trust me, I'd love to sit down with a massive big fillet steak and just be able to tuck into it. But I can't. So Sharon will say, well, why don't you try it? Why would I want to pay £25 to try a bit of fillet steak and then give it the dog when I get home?
What we're talking about here, Chris, is we're talking about the psychological side effects of a lack of saliva. So the work that Elaine is doing with her team in trying to re-stimulate the production of saliva from whatever undamaged tissue is left is not only going to create an opportunity to avoid the actual physical symptoms of the dry mouth, but might actually make a huge contribution to the psychological well-being of the patient and their caregivers and families that surround them, because this impacts on everybody.
Yeah, and I'll tell you what, when Elaine's ready to put this in test to patients that are suffering with it, I will be fighting to be at the front of the queue. And I don't like pain or needles, but I tell you what, I would fight, and I bet I would be fighting with hundreds of others to be at the front of that queue, because that's how important it is to us. And, you know, if you ever want to try what dry mouth is, try the cream cracker challenge. The cream cracker challenge is you get a cream cracker, no butter, no water, no nothing on it, and put 6 on a plate. Try and eat as many as you can in a minute. And I will guarantee nobody will get past 4. And that's what dry mouth is. Even nurses that talk about it, when they do that, they have a different opinion on it. So I've got a research question to ask you.
Go ahead.
And I'm never scared to ask research questions, because I think research, the trouble with the public is the research is so far away that it's not going to affect them.
It's basically back and forth, testing things, making things better, I guess discarding the things that don't work, and just ultimately progressing.
The other thing that I always get asked about when you talk about research is mice. It's, if you like it, it's the elephant in the room, but it's a mouse in the room. I was amazed when I went to a conference once talking to a researcher that does research in nothing but head and neck cancer. That's all this guy does. And he talked about, he'd found in his research that actually there's black mice and white mice. And his black mice in head and neck are more closer to the human head and neck cancer than the white mice. And again, I thought that was amazing. But how do you deal with, do you use black mice or white mice, but also how do you deal with it when someone says it's very cruel to use mice?
Yeah, it's a very emotive subject, and it's something that has always been a big part of my research career, but it's always something that I am very aware of, very conscious of, and it's absolutely something that if we didn't need to do this, then we wouldn't. So just to kind of give you a bit of background, certainly from the UK perspective, animal research across the board for medical research is incredibly tightly regulated, and it's regulated through the Home Office. It requires justification of everything that we're doing. So all experiments have to be justified and have to be done for a specific reason. Everybody that's involved has to be very extensively trained. We have to report back annually, and it's something that there's an awful lot of effort going into trying to replace animal experimentation, or to refine methods to get better methods that require maybe less invasive procedures or less, I guess, pain or suffering. It's something that's really actively going on at the moment, and people are always trying to develop methods that require either less use of animals or less highly complex animals. So there's very little research done now in very kind of complex animals like apes, for example, non-human primates. But unfortunately, it is something that is still required at the moment. And for things like cancer research, where you've got a very complex environment with lots and lots of different organs, lots of different cells that are all interacting. It's unfortunately incredibly difficult to mimic that in a laboratory, in an incubator. People are getting much better at doing that, and these things are becoming much more widespread in their use. But until we're at a point where we know that those models completely recapitulate what's happening inside a human body or inside an animal body, we unfortunately can't really do research without the use of animals.
Again, speaking to this research guy, he was telling me that in their lab, they actually employ someone whose main role and main job is just to look after the health and well-being of the mice. That's all his job is. And even to the fact that the guy that is involved, and I spoke to him, sleeps in there sometimes if he's got a poorly mouse. He really does take them to heart, and it's his main job is to do that, which I thought was incredible. Yeah. But the other thing I found fascinating was, and I didn't know until maybe 3 years ago, that the surgeons will also, as part of their training, do operations on rats, because their body and their veins are very, very similar to ours in the neck and the neck area. So if they can do an operation on a rat, they can do an operation on a human being. Mm-hmm. And again, I just thought that was very, very fascinating, because they actually do the operation, put the rat back together, and the rat lives.
The Swano's Charity Head and Neck Cancer podcast is designed to help and support both patients and caregivers.
How close are we to transferring your research actually into patients, human patients?
That's a really excellent question. So we're not there yet. So that's one of the things actually I strive to try and highlight is the kind of pathway through what we call basic research, translational research, and then into clinic, into man. And that's actually an incredibly long process. The reason being that we want to make sure that these things work, that they're safe, before we obviously start putting them into people, and especially into people who've been through really extensive treatment already for cancer treatment, for example. So these period of time can take years, even decades, to get through. And that's just the system of medical research and of clinical trials. And probably your audience are actually probably a lot more aware of this now after this last year than they maybe were before, because we've heard so much about the COVID vaccines and how they've gone from this really basic research in a lab right the way through to small scale clinical trials where you test in a small cohort of people, and that's really to test safety, and then scale up to a larger cohort, and then you can start seeing results and seeing whether you're seeing an effect that you would expect and whether you're seeing a positive response. And obviously this last year, that's happened incredibly fast because we've been in a situation where we've needed to move quickly. But in a normal situation, that can take years. So my thoughts are, my group are at the moment at the stage where we would consider our research translational. So we're not at that really basic stage. We're at the stage where we're looking at things that could, in a few years' time, be applicable to man trials. But I think we're still a few years away from that, but hopefully we'll get there, very soon.
So I have to ask you a question about COVID, because you mentioned COVID.
Yeah.
I can't ever remember a time in my very short life, because I'm only 21, what COVID does to people and how we've had to deal with it. I think the government have done a phenomenal job. I would not have wanted to be in government for love nor money. And I certainly think our health authority and our National Health Service was phenomenal. I'm so glad that I live in the UK because of that. But being someone that gets involved in getting new drugs to market for head and neck patients, and knowing all the rubbish sometimes and the red tape you have to go through, and how the researchers' hands are tied because they don't get the money to do stuff, which could make a difference massively to a lot of people. What's your thoughts of how quick, they got the COVID drugs through, which I'm really pleased they did, mind you, and how all of a sudden all that red tape was taken away.
Mm.
How does that make you feel?
So on one side, I would say that there's been no change in terms of the red tape, from my understanding. The researchers still had to go through all the very stringent testing that it would have done in a normal kind of timeline. It's just been able to be overlapped a bit more. So normally what would happen is you would have a sort of phase 1 clinical trial. So this would be a small cohort of people. It would run for a certain period of time. It would finish. You would then go on to data analysis, and there'd be a really extensive period of that. And then you would then move on to, say, the phase 2, which is a larger cohort of people. For the COVID vaccines, those have been overlapped to allow for things to move much quicker. And that's allowed the same safety precautions to be there. So people have still been certain that the vaccines are safe in that very first trial, but they've been able to start the next one and start expanding and start getting results on whether it's working before they would have done in a normal situation. So things have definitely sped up from that point of view. I do think that we've probably learned some lessons, though, from this last year, in the sense that, there's lots of clinical trials that have happened before that have taken probably much, much longer than they needed to, and have actually subsequently cost a huge amount of money as well. So I think moving forward, I'm hopeful that we'll have learned a lot from this, and that can then be fed into future clinical trials for everything, not just for a kind of situation of a pandemic.
I take your point about the trials, but someone had to develop that drug. They weren't developing that before COVID got here. So all of a sudden, one Friday night, they get a call, a lab somewhere gets a call from the government to say, you've got unlimited budget, but I want it delivered by 4 weeks today. Unlimited. I'm sure if I give you an unlimited budget, your research would come to fruition a lot quicker. That's the bit I think is wrong, that it takes a pandemic like we've just been on to suddenly realize that people like you struggle like mad to develop things that can make a massive difference to people's lives. And I'd like to see the government realizing that and going forward, no matter what government is, whether it's Conservative, Labour, but someone's got to say, do you know what? That worked. And look what difference it made. Now let's see about getting researchers more money. Because without you having money, you can't do it.
It's unfortunately possibly one of the biggest hurdles that we have is lack of funding. So like you say, we can't do any of the research without funding, and that goes for paying people to do the work. It goes for all of the equipment and the day-to-day running of labs, the use of very complex machines, and unfortunately that is not cheap. But we're in competition with so many other scientists who are all pitching really important and really exciting research proposals, and there's only a limited amount of money. So
we've been talking before this about your lab. You do a 3D tour of a lab, which is phenomenal. Anyone that wants to look what a lab does, go on the website and you can see it. But we were talking about doing a small film about your work and your work within head and neck for the swallows. And we can't even get funding for that.
Yeah.
And without that, how can we tell people the work you're doing? And if you want to talk about this wonderful work to get funding, you haven't got funds to be able to talk to someone about getting funding.
Yep.
So if there's anybody out there now that wants to donate some money for us to create a film, I would take it at a heartbeat, because I think the work that you do for head and neck cancer needs to be out there so everyone knows about it. So my plea to anyone listening to this now, please, please, please get in touch with the Swallows and look to fund a small film that we can then put out there about the work you're doing for the salivary glands.
The pandemic, obviously, as Chris has already intimated, created a fast track to getting a result. There's some, the other thing that has done that, and history has proven it over time. War does exactly the same thing. Mother of invention. Have a war and suddenly things start to happen. Not that I'm suggesting that, nor would I ever suggest we go through another pandemic. But my question is that during the pandemic, we had the COVID vaccine being developed, and it was being developed in multiple places by multiple groups in multiple countries. And I'm guessing that there was an element of mass collaboration taking place at that point. Now, my question to you is, who else is looking at the work and research that you're doing, and have you got any ability to collaborate with outside resources that would speed, help, push along your research?
Yeah, no, that's a great question. Yes, there are other people internationally who are looking at this. So, for example, there's a group in the Netherlands who have been really pioneering in the idea of basically isolating the stem cells from human gland and then growing them in a lab, and then with the idea that you can sort of enrich for the stem cells within this growing culture. They can form these small branching structures that we call organoids. They kind of resemble a salivary gland in the sense that they've got these cells that look like the Asana cells that would produce saliva. And they're actually just about to start an in-man trial to transplant these back into radiation-injured patient salivary glands. So that's a fantastic trial. That obviously would be very complementary to our work. So especially if we want to try and make the gland environment something that's more hospitable, and try and correct anything that's happened with radiation injury, then the two approaches together would be really complementary. There are also other groups in the US, for example, who are really heavily studying development of the salivary gland, with an idea of understanding, if you know what happens during development, maybe you can try and work out what doesn't happen in adulthood, but what could happen that could be a sort of regenerative strategy. And that was actually one of the labs that I joined when I worked in the States for a couple of years. So that's where that sort of idea of using development as a tool to study regeneration came from. And then finally, you've got a number of groups across the world who are looking at the idea of whether you can create a sort of scaffold to deliver cells back into an injured salivary gland. So whether you can use bioengineering to create something that you can then put the cells inside and then put that back into the gland, and whether that creates a sort of, again, a hospitable environment that is much more conducive to the cells being happy, and being able to integrate into the tissue and actually repair the injured tissue that's happened during radiotherapy. So I think all of these things are really complementary, and I'm fully on board with the idea of collaboration. I really think it is the way forward in science. I think that you can be one person working on one thing, but you are never going to have the expertise and the knowledge and the know-how to be able to do something as complex as what we're looking at on your own. So I think collaboration really is the way forward.
What I was going to ask you next, Elaine, was do you have to sit back and wait for publication of the other team's results, or are you able? Is there a willingness to communicate? Via, we've all learned. We've all learned that this Zoom thing is marvelous. You can actually talk to somebody in real time, and you can see what they're doing at the same time. So, is there a willingness to collaborate in the way perhaps the COVID vaccine people collaborated, or are you still in the, and I hate to use this phrase, but the sort of the dark ages? You've got to wait until the secret is out via a published paper before you get to know anything about it.
I'd say we're somewhere in the middle.
Right.
I think that there are certain aspects where we are kind of party to unpublished data before it gets to that stage, and conferences are an incredible way to see that. So there are a couple of very specific salivary gland conferences that we try and attend, and obviously that's something that's been lacking over the last year. But that's usually a really good way to disseminate unpublished results, and especially unfinished studies. And I think that's where a lot of collaboration comes from. And then obviously there is then the published route, and we do find out a lot of really exciting information after it's been published as well.
So that's brilliant. This has been one of the most fascinating insights to medical research that we just don't hear about. I mean, this just goes on in the dark background, and the results at the end of the day are only brought to our attention when we sit in the chair of the specialist surgeon, oncologist, and get told this is the treatment we're going to have, and we have no understanding of where it's coming from. It's been a fascinating talk. Chris, have you got anything that you'd like to ask Elaine?
Oh, I could seriously, Derek, I could spend a whole day on this subject.
I know.
Because this subject is, I just feel that people don't realise what work is going on at the moment and how important it is that, if you've not got cancer at the moment, this work is so important, yet you don't think it is. And when you've got cancer, it's too late because you're in that journey. You're only dealing with what's been invented now. Everyone gets a mobile phone. By the time you've got the damn thing, they've already got 3 in the background waiting to come out when you've just spent £500 for an iPhone. Yet they've got 3 more to come out when that one's gone. So I think research has got to come to the front more, but it's got to be driven that it's disease orientated, because that's the only way we can bring, Cancer Research UK do a great job. But what do they do research on? Virtually everything. Mm-hmm. That's no good to me. I want research on head and neck. Mm-hmm. Because that's my disease. That's what I specialize in, if you like. I don't want research on breast as much as they would fight for their bit. Mm-hmm. So I think having people like Elaine on here and being involved with her team and having her at the conference that we do every year, do you know what? It's incredible. And I hope to work more and more with Elaine going forward and her team going forward with the film idea, with the 3D idea, and I'm hoping that we can get more of her team on the podcast going forward as well.
That'd be great.
Absolutely. If we can get the funding for the film idea, Chris, we'll get Elaine and the team back to take us through, how we've moved on and where we're at and what the latest is and what we can hope for. Because with research at our end, as the patients and the caregivers, we just have hope that you guys at the front end can deliver, these phenomenal inventions and ideas, and more importantly, that you can deliver them on a timescale that we can take advantage of them, which obviously and tragically isn't always the case. But that doesn't mean we shouldn't keep doing it. Yeah. Chris, magic one time.
I think the first start is trying to get a film done. We do need a bit of funding, but it's not a lot of money in the big scale of things. We're only looking at a maximum of £2,000. Think what that £2,000 is going to do for tomorrow's patient. It's little money. My pledge is to try and get this film created and work very closely with Elaine and her team to make sure we get it all over our website, around the conference, and as much as we can do, because salivary gland and dry mouth has got to stop. So once I set myself a target, I don't stop until I've got it.
Elaine, I'd like to thank you very much for giving us your time today. If there's anything that I haven't specifically asked you about that you would like to bring to the front, now's your opportunity.
No, I think you've covered everything really nicely. I'd just say if anybody's interested at all in knowing more about our lab, we're on Twitter. You can also find us on the university website. So if you search my name and the University of Edinburgh, you'd find plenty of information there, and things like the virtual tour that Chris alluded to. And yeah, if anybody has any questions, my email address is also on there, so do feel free to get in touch.
Indeed, I've been on that site and had a look through it, and I encourage anybody and everybody to jump in there and have a look and see what's going on. And bear in mind that what we've talked about this morning is really just about the head and neck, so the salivary glands that have an impact on a head and neck cancer patient. There is research going on across all sites, all types of cancer research for all parts of the body, and as Chris has already alluded, our speciality and our interest is definitely in the head and neck, but any support given to all research is gratefully welcome. Please go ahead and donate as much and as often as you possibly can. I, on behalf of the Swallows, would like to thank Dr. Elaine Emmerson for spending valuable time with us talking about this phenomenal area of research. We wish you the very best with the research as it goes along, and I keep my fingers crossed that it'll arrive sooner rather than later.
Yeah, no, thank you very much. Thank you for the opportunity as well. It's been wonderful.
Okay, you can contact the Swallows at www.theswallows.org.uk, or you can contact us on info@theswallows.org.uk. Twitter is the Swallows Group, or just go on Facebook and put in Swallows Head Neck Cancer, and we're all over the place on Facebook. We're on Instagram, but don't ask me what that is because I haven't got a damn clue. I don't do Instagram. But our important one is our 24/7 support line. As you know, Derek, it's open for patients and caregivers. If you're a caregiver, you'll get through to Sharon, my wife, who was my carer, and my boss. So it's, and if you're a patient, you'll get through to me. So it's not a call center. I keep saying that. It's not a call center. I think last night, well, early hours of the morning, myself and Sharon took a call from a patient at 2 a.m. in the morning, and we were on for an hour and a half. And then we were up again at 7:30. So it doesn't matter what time you ring, you can call us. So it's 07504 725 059. Ring 24 hours a day, 7 days a week. We're here to take your call.
Thanks, Chris. Thanks very much. And once again, a big shout out, big clap, big award, big thank you to Dr. Elaine Emmerson for joining us in this particular podcast. We look forward to talking to you again in the not too distant future. Keep tuned in. Send us your comments. We want to know about your likes and dislikes. If there are any topics or particular subjects you'd like us to cover in these podcasts, we'll do our best to provide them. Otherwise, you get what we can provide. We look forward to speaking to you all again. So it's a big goodbye from me. I'm the quiet, good-looking one. And from the noisy, ugly one,
it's a goodbye from me.
Cheers, everybody.
You've been listening to the Swallows Charity Head and Neck Cancer Podcast. For more information, please visit www.theswallows.org.uk. We hope you'll join us again next time.